Hey people, welcome to my YouTube channel. And today we are going to look into Dash and Streamlit. Okay, so before that, let's understand what is Dash and Streamlit. Just give the difference. Okay, we'll be building a simple project using Dash and Streamlit. So basically, these are like web apps or UI interfaces designed for data scientists, which are most commonly used. Okay, so before that, let me uncomment the starting understanding and let's comment this part. Yeah, I think this from here till bottom. Okay, so you can also mention this in your CV. Okay, what you're trying to build, and then you can try to bring your own imaginations here and make it better. Okay, so if you see, Dash is like the feature, it's developer. We use Plotly here. Plotly is basically for graphs like matplotlib, and Streamlit is basically the part of snowflake it is saying, but Streamlit is, we'll understand, it's a UI interface. Okay, this also uses pure Python but uses Flask under the hood, and Streamlit is pure Python basically. UI design, it's more control and flexible. Okay, and a simpler auto layout, less control. Okay, learning curve, it is deeper, it says it's easier. Custom components are supports advanced customization in case of Dash, but this has limited but improving with extensions. This is for production apps and for great for prototypes and internal tools. Okay, we can build complex dashboards and apps using Dash, and MLDS applications you can see using Streamlit is built. Okay, deployment is manual using Heroku and AWS. Here they have Streamlit Cloud itself to deploy the app. Okay, so this is like the basic understanding between Dash and Streamlit. uh, Explain what are they. Let's see this once and then we can go ahead. Okay, so what is Dash? So Dash is a Python framework built by Plotly to create interactive web applications and dashboards. So this is Dash. Okay, and Streamlit is super easy and faster to build data apps and ML dashboards using Python scripts. Okay, so you can go through the other descriptions. Okay, or the details by yourself. So oh, okay. So let's run first Streamlit since it is easy. Okay, so to run the Streamlit app, what you need to do is we need to write Streamlit run and the your Python file name str.app underscore app dot py. Okay, so when you hit enter, it opens a web interface here. Okay, let me close this. If you see first Streamlit app, it is saying, and enter a number. So this is the default number. Okay, let me explain the code here first. This is the heading which we are getting here, first Streamlit app, and it is asking for enter a number, and value 1, it is the default value. Okay, so that is the reason without any input it is giving 1. Okay, and square value 1 is, this is what it is giving, st.write. Okay, so what we need to do here is, before that, first we need to import Streamlit as st, numpy as np, for and plotly.express as px. So this is for plotting the graphs. Okay, for graph plot, I'll push this code so you can try it out if you're using. Okay, now what it does is num is equal to st dot number input, it takes the input. Okay, and square, what it does is num raised to 2. Basically, I mean, exponent of 2 is basically here's the square. Okay, now np dot linspace, now this creates 100 data points from 0 to num. So whatever num we specify here, okay, this input, it creates 100 data points from there. And y is, this is on x-axis, and y is on y-axis, which is basically the square, and figure is basically px dot line. So px is this extension dot line, and here x axis is x basically, which is this, y axis is y, and labels is x I'm defining as input and y is equal to square dot output, and finally st dot plotly chart and fig. Okay, so this plotly chart basically plots the graph. So if you see, square output is y-axis, this is the input as we are given. So if I change this number to, let's say, 6 and hit enter, it gives 36 squared value. And if you see, from here 0 till 6 it is, okay, and the highest value is, if you see over it, it's 36, 6 and 36. Okay, so if I go to 5, I cannot go exactly at 5, but yeah, 5 is 25. Okay, similarly for 4, or yeah, 4 is 16. Yeah, I reached exact point. Okay, so this is like a Streamlit app. Okay, so let me run. Okay, let me stop this. Okay, and let me run the dash app now. Okay, so it's a similar. Okay, so you can directly run this, no need to specify. Okay, so my dash is running, and if you see, it says dash is running on HTTP here. Okay, I can click it here. Now I can go here. Okay, and if you see, Streamlit has this symbol which like a king, like, or a, what it is called. Okay, anyway, which is this, and dash has this symbol. Okay, now if you see first dash app, let me explain the code here. Input dash, dash input. DCCs are components, dash components. HTML is for layout, and dash or dependencies import input output. Now this takes the input from the user and maps to the output. Okay, and similarly plotly and null. Now app.dash name, which initializes the app, and layout is basically HTML div. Okay, your first dash app, this is basically the title. ID is num. Now in case of dash, what we need to do here is, we need to specify like the components in the form of a format of HTML. Okay, so ID is num here and ID is plot here, so which distinguishes between like the number of inputs. Okay, now type number value is 1, so here also it is like default is 1, and square output is 1, and if you see, similar plotting is done here. Okay, now if you see, there is some differences in case of dash.app dash app. So we use callbacks here, app callbacks. So output comma children is one output. So basically whenever we give the number, it triggers these things. Okay, and input is basically, it takes the input from this, where it is, yeah, this one. Okay, and second output is basically this plot. Okay, so first output is directly the input output, and second is the plot. So how it updates is, once it initializes this app.callback calls this function internally. Okay, and it identifies itself like what needs to be done. So first it calculates the square, if you see, num, if num else 0. Okay, and similar, it creates the 100 data points, and y is initialized like this. And similarly we create the fig, text.line x, y, and labels is input output, and return f dot scaled output square, if you see, squared output and square. Okay, and finally the fig. Okay, the figure here. Okay, so if you see, if I take this DCC graph from here and here and save it. Okay, so comma. Okay, I forgot comma. Okay, if I save this, okay, it's not running. Okay, I need to run it again. The layout changes basically. Okay, let me refresh this. If you see, now the input has gone down and the graph has come up, but if I write here 5 and hit enter, the square is 25 and it goes up to 5. Nothing changes, but however you design this, right, like if I put it upwards and downwards, the layout changes basically. Okay, so let me do it as is, and let me refresh it. Now it goes like this. Okay, so you can increase from here also. You see, it changes automatically. Okay, so this is like the difference between dash and Streamlit. Okay, so one application we have created, so let me uncomment this. Okay, and a simple finance tracker basically. Okay, and save it. So let me refresh this. Okay, I need to rename again, I think. Okay, let me rename this again. should ideally refresh, but yeah, may reason or yep, it's not working. But yeah, let me close this. Okay, and let me rerun this again. Okay, now this is personal finance tracker. Okay, you can go through the code easily. A simple project basically to understand the difference between the dash and the Streamlit. Okay, same interface I have built. So it asks for your total income, rent, food expense, travel expense, and other expense. Basically gives us the financial summary and graph of your what it says, expense versus income, and finally your savings if you have saved it. So if I say, just for the example, let's say 50k is your salary, rent is around 7k, okay, and food expenses, let's say 10k monthly, travel expenses around 4000, and other expenses, let's calculate, is at 5000. Okay, okay, something happened, but yeah, 50,000, rent is 7,000, food expenses 10,000, travel is 4,000, other expenses 5k. Calculate insights. Okay, so if you see, let me close this. Total expense is 26k and savings are around 24k. And if you see expense distribution, we get a pie chart basically. If you see food, rent, other, and travel. Okay, so this is the layout here for expense distribution. And income versus expenses like this. So this is our income 50k, expenses are around 26k. Okay, and this is our projected savings. So basically it took 24,000 as a savings and the projected graph and projected amount. So every month it calculates its own amount and finally it gives us the estimated savings. Okay, so what you can do is for improvements, you can ask it for any other suggestions how I can reduce some of the expenses, or which is the expense scenario here where I am uh, expending money much. Okay, and also you can ask for another pie chart which gives us like overall spend versus expenditure, right? And also you can add any other things which you feel like, right? So let me run this also. Okay, I need to close this. Okay, let me, yeah, this one. Okay, so this is also the, okay, I did not uncomment it. Okay, I can also take you to the code at the end, but yeah, yeah, so I don't know whether this, yeah, this works. So if you see, I need to give here 50,000, 50,000, rent is around 7,000, food expenses 10,000, travel is around 4,000, yeah, there is around 5k. Okay, now let's, if I hit on calculate insights, if you see 26 is a total, savings is 24k, and expense breakdown distribution similar to the this. Okay, and income versus expense and future saving option. Okay, here I have added some additional insights, financial insights and savings. It says great to have a healthy savings ratio and other saving options it also gives. Okay, but let's say if I go and here give 14k here and 15k here and calculate insights here. Okay, still it goes, and if you see your travel expenses seem high, explore public transport or carpooling options. This gives some suggestions. Okay, so in this way, like, you can add on improvements and see which is better for your thing. Okay, so if you want a simple code workflow, this is the workflow. So basically page title is finance tracker wide, and gives us like this is the title here, and column 1, column 2, these are two columns created, and first one is monthly income. Basically it asked for an input and then it calculates. Okay, and in column 2 basically it gives us the summary. So basically this is considered as column 1 and this is the column 2. Okay, and subheader breakdown is this is like the pie chart. Okay, this one, expense distribution, if you see here. Okay, and this is the bar chart. Okay, this one. Okay, and this is projection. Okay, and this is like the plot or the annotations which are available here. Okay, and finally it gives us like the insights. If it crosses, like if you see food is greater than 0.3% of income, 0.2% of income, 0.4% of income, it gives us suggestions. And finally the normal info, which is like the fixed, this is fixed scenario. Okay, so in this way, this is for the Streamlit, and for Dash it is this similar way. If you see, there is an app layout here. This takes DCC input, and this is for the output. Okay, output block. This is for the graphs. 3 graphs are there totally. Okay, one is chart, one is bar, and exponent ratio. Now if you see in the callback, first children is basically for input. This is for pie chart 1. This is for bar chart. Okay, and this is for the graph. Okay, the line chart. Okay, and if you see the input here, calculate and clicks income value, rent value, it takes basically the other inputs. Okay, and update finance based on that, and summary. Okay, these are the labels it gives, category. So if you see at the Dash app, it is like a bit complicated, but yeah, you can try it out. And everything is inside the function. If you see, this is the function, and it returns summary, pie chart, bar chart, and line chart. Okay, so everything is defined in the function, but it gets called internally only when this is triggered. I mean, if you change something from here, not from here, if you change something, this gets called internally. Okay, this function, because it, if you see update finance, it is not called anywhere. If I see update finance, the it occurs only once, which is this. Okay, it is not called here, right? So it gets called by apt callback, which acts as a wrapper function or decorators, you can say. You can look at the decorator concepts and you can write out. Okay, so basically these are some simple projects or simple basic project using Streamlit and Dash. Okay, so hope you learned something from this video. I will push the codes in the GitHub and mention the links in the YouTube video once it is uploaded. Okay, so yeah, if you learned something from this video, do like, share, and subscribe. And till then, take care. Bye bye.